Hello, everyone. In this lesson, we will learn about the construction and acceptance of grass swales. From previous lessons, we know that a grass swale is a vegetated surface channel that can collect, convey, and discharge stormwater runoff, and has a certain capacity for rainwater purification. Grass swales are commonly built around impermeable surfaces, such as roads, squares, and parking lots. They can serve as pretreatment facilities for sponge infrastructure like bioretention facilities and wet ponds. They can be used to connect various other facilities. Urban stormwater pipe systems and overflow discharge system. Grass swales are generally divided into conveyance type grass swales and ecological retention grass swales. Taking conveyance type grass swales as an example, its structure, from top to bottom, typically includes an overflow layer, storage layer, and planting soil layer. Additionally, grass swales include other facilities such as inlets, overflow wells, drainage blind pipes, and check dams. As for ecological retention grass swales, their structure is similar to that of bioretention facilities. Next, we will learn about the general regulations for the construction of grass swales. The size and number of rainwater inlets and outlets in a grass swale should meet the design requirements. When gravel or pebbles are used as energy dissipation measures at the inlet, the size distribution of the gravel or pebbles should comply with design requirements. The check dam section of the grass swale should be constructed according to design specification, as shown in the diagram. For the Ministry of Housing and Urban-Rural Development, Sponge City Construction Technical Guide specifies that the cross-sectional shape of shallow swales should preferably be an inverted parabola, triangle, or trapezoid. The slope of the grass swale should not exceed 1 to 3. The longitudinal slope should not exceed 4%. If the longitudinal slope is steep, it is advisable to set up a step grass swale or install energy dissipation terraces midway. The particle size of the planting soil should not exceed 5 centimeters. The compactness of backfill soil should not be too high. Mechanical compaction should not be used when medium or coarse sand is mixed into the backfill soil. The grain size and mixing ratio should comply with design requirements. When near roadbeds or buildings, geomembranes or geotextile should be laid according to design specification. The performance and dimensions of the geomembrane or geotextile should meet design requirements. The construction of the grass swale should also meet design specification. Now, let's take a look at the construction process of grass swales. The construction process for grass swales should be reasonably determined based on the structure of the facility and site conditions. The general procedures are as follows. First, prepare for construction and conduct measurements and line marking. Then, carry out earthwork construction. Construct the overflow wells and drainage layer. Carry out planting soil layer construction and plant the vegetation. Let's first look at the measurements and line marking. The construction of grass swales should ideally begin after the completion of the catchment area. For example, after the surrounding greenery planting and road structure layers have been completed. At this point, line marking can be done according to the construction drawings. Set up control points. The position of the inlet should be adjusted based on the completed catchment area and the actual flow path. At the same time, the vertical elevation of the facility should be measured with the elevation of the catchment area. At the inlet as the reference point, lay out the boundary lines on both sides of the grass swale according to the design location. Usually, place a point every 20 meters on straight sections. and every 10 meters on curved sections. After marking, protect the control stakes. Set up guide stakes if necessary. Next, let's look at the earthwork construction. First, clear the surface. Remove weeds, gravel, and other obstacles from the surface, where the grass swale will be constructed, to keep the surface level. Then, remove any standing water. If there is standing water, a small pit should be dug at the start of the trench to drain the water. Excavate the trench according to design requirements. Dig an appropriately sized trench on the surface. Typically, the trench depth is about 20 to 30 cm. The channel of the grass swale should be constructed according to the design form. The surface should be level and compact. The trench should avoid heavy machinery compaction to maintain permeability. This is to prevent the reduction of soil permeability in the base layer. If the soil has been compacted, the soil within a depth of at least 300 mm in the base layer can be tilled. To restore its permeability, the slope of the grass swale is usually between 2% and 5%. To ensure smooth water flow through the swale, check every 5 meters to ensure consistency with the design slope. The cross-sectional shape of the grass swale should be strictly constructed according to design requirements. The cross-sectional surface should be level and free of large stones and gravel. The slopes can be lightly compacted to ensure stability. The side slopes along the longitudinal direction should be consistent. The alignment should be smooth and aesthetically pleasing. For the drainage layer construction, the drainage layer should consist of clean gravel or crushed stone materials that are free of impurities. The thickness of the drainage layer and the grain size of the gravel should meet design requirements. If the design is not specified, the thickness should be between 250 to 300 millimeters. Ensuring that the drainage blind pipe is covered. The top and bottom of the drainage blind pipe should have at least 50 millimeters of gravel layer. The grain size of the drainage layer should be controlled between 10 to 20 millimeters. The minimum grain size should be no less than 1.5 times the perforation diameter of the drainage blind pipe. The grain size of the drainage layer should be uniform. To prevent leakage of transition layer media due to wide grain size distribution, the grain size should be set to 3 times in a dry condition. To prevent incomplete sieving due to moisture adhesion, after the drainage layer is wet, it should be lightly compacted to ensure the flatness of the drainage layer. Care should be taken to prevent damage to the drainage blind pipe during compaction. Next, let's look at the construction of the planting soil layer. The requirements for planting soil are as follows. It should meet the requirements for salt content, pH value, etc. It should also be loose in texture, have an aggregated structure, possess certain fertility, and consist of topsoil with a depth of over 80 centimeters. The process for constructing the planting soil layer is as follows. Before filling, any garbage and debris on the base soil should be cleaned. Carefully conduct soil quality inspection. Check the type, grain size, and presence of debris in the backfill soil, and control the moisture content of the soil material. Within the design range, carry out layer filling. The thickness of each soil layer should be determined based on soil quality, compaction requirements, and equipment performance. For plant planting, the plants should be arranged according to the design drawings or planning requirements, and placed in the trench at specific intervals. The spacing should be determined based on factors such as the plant growth rate and trench width. Dense turf should be planted. Trees and shrubs are not recommended. The height of the vegetation should be controlled between 100 to 200 on. First, plant the slope and side slopes. Then plant the bottom of the trench, as shown in the diagram. Before planting the bottom of the trench, confirm again that the slope and shape have not been disturbed. Dig planting holes with a size suitable for the plant's root system. Then place the plant and compact the soil. The soil should be lightly compacted to ensure close contact with the plant's root system. This promotes plant growth. After planting, maintenance is necessary to ensure healthy plant growth. During rainy season construction, measures should be taken for drainage and soil retention. Next, let's look at the construction of inlets. Should be lower than the catchment area to prevent water obstruction. The inlet and outlet should smoothly connect with surrounding drainage facilities. When the slope of the inlet and outlet is steep, pebbles or step faults should be used as energy dissipation measures. When laying energy dissipation terraces, the stones should be well graded and clean. They should be laid directly without mortar. The elevation of the terrace top should be strictly controlled according to design requirements. If the grass swale is in a low-lying area, and no drainage measures are specified in the design, drainage facilities or a sump should be installed during construction. Overflow facilities are an important part of grass swales. The elevation of the overflow well should strictly follow the design requirements. Elevation control should refer to the elevation of the inlet and the bottom of the swale. If the design drawings are unclear, a small drainage pipe should be installed at an elevation of about 0.2 meters below the surrounding ground to guide drainage. This ensures that excess collected rainwater is discharged in an organized manner. The elevation of the check-dam top should strictly follow design requirements. It is generally determined based on the longitudinal slope and depth of the grass swale. This ensures that, even with a steep longitudinal slope, the dam can retain water, reduce flow velocity, and prevent erosion of the swale bottom. The above covers the construction of grass swales, the main construction methods, and points to note. Next, let's learn about the acceptance of grass swales. The acceptance of sponge city facilities should be jointly conducted by the construction unit, design, construction, supervision, and related units. They should check whether all parts of the project are complete and whether the associated facilities are reasonably arranged. Generally, when accepting sponge city facility projects, the following documents should be available: construction drawings, completion drawings, and design change documents, certificates of conformity for major equipment and materials, test records, project contracts, and tender documents, including concrete mortar, welding, permeability tests, pressure tests, and full water tests, as well as records of various tests and inspections. Records of concealed work acceptance and intermediate test records, pipe flushing records, and pressure test records for pipes and containers, project quality accident handling records, project quality acceptance evaluation records, equipment commissioning and operation records, etc. After the sponge city project is completed and passes engineering acceptance, a functional acceptance test is recommended. The content of functional acceptance depends on the project requirements and may include indicators such as annual runoff volume control rate and annual runoff pollution control rate. It can also be evaluated based on the overall reasonableness and implementation effect of the sponge city master plan. The above describes the acceptance process for sponge city projects. This is divided into engineering acceptance and functional acceptance. We can refer to the standards for construction and quality acceptance of sponge city infrastructure. The grass swale project acceptance. Items are mainly divided into main control items and general items. Let's first look at the main control items. The cross-sectional shape and size of the grass swale for water passage should not be less than the design requirements. Pollution blocking facilities should be accurately set at the inlet. The inspection frequency is recommended to be one inspection every 20 meters. The inspection method is measurement, the survival rate of the vegetation in the grass swale, and the height of the vegetation should not be less than the design requirements. The inspection method is also observation and measurement. The elevation and location of the overflow inlet should also meet design requirements. The inspection method is also observation and measurement. The general acceptance items for grass swales are as follows. The grass swale should have a smooth and aesthetically pleasing alignment. There should be no debris inside the swale. It is recommended to inspect every 20 meters. The inspection method is leveling and observation. The width and slope of the grass swale and the elevation of the bottom should meet design requirements. It is recommended to inspect every 20 meters. The inspection method is also observation and measurement. Summary of the content of this lesson. Learned. General regulations for grass swale construction. The construction process of grass swales. The main construction methods and precautions. And the acceptance of grass swales. We first provided a detailed introduction to the documents required for Sponge City project acceptance and the content of functional acceptance. Then we introduced the specific items for grass swale project acceptance, divided into main control items and general items, and provided the inspection frequency and methods. Alright, that's all for this lesson. Goodbye, everyone.